Yep. Okay, I started recording now. So we have multiplication of vectors. One type is scalar or dot product of vectors, and the other one is vector or cross product of vectors. Vector or cross product of vectors. We'll discuss this later. So today I will take this scalar or dot product of two vectors. Okay. So multiplication of vectors, in this multiplication of vectors, this has been classified into two types. One is a scalar or dot product of vectors, and the other one is vector or cross product of vectors. Now let me show you dot product or scalar product of vectors. So dot or scalar product of vectors. Also, we'll discuss the properties as well. The properties of dot product. Dot, the name itself says dot means I will put dot between two vectors. Dot between two vectors. Actually, it is defined as, for example, if I consider two vectors like this, A bar is one vector and B bar is the other vector. If I consider two vectors A bar and B bar, then the dot product of two vectors is defined as A bar dot B bar, A bar dot B bar is equal to, it is defined as the product of the magnitudes of two vectors, product of the magnitudes of two vectors and cosine of the angle between them, right? And cosine of the angle between them. Now, can I write simply this modulus of A bar as simply A? Modulus of A bar I can write as simply A, right?
Yes, sir.
A into modulus of B bar I can write as
B.
B into cos A bar dot B bar. So this is the formula for dot product of two vectors. A bar dot B bar is equal to A B cos theta, where A is magnitude of A bar, B is magnitude of B bar, and theta is the angle between, or I can say cosine of the angle between the two vectors A bar and B bar. Now let me show you diagrammatically, right? How can you draw? See, as I said, multiplication, it will come under multiplication of vectors. Here I am multiplying two vectors, A and B. I am multiplying these two vectors, multiplying the magnitudes of the vectors. Now, if let me show you the graphic, or diagrammatically. For example, I have first vector as A bar, second vector as B bar, second vector as B bar, right? Now, theta is the angle between A bar and B bar. Now, how can you resolve vector B bar? Vector B bar is not allowed. See, can I take this as x-axis? Can I take this
Yes,
as
sir.
x-axis?
X-axis.
Right?
Yes,
Can
sir.
I take this as
AX,
y-axis?
BY.
Yes, sir.
No, I cannot take. Let me show you. This A bar I can take as x-axis, but what about B bar? What about B bar?
We cannot take, sir.
Resultant, sir.
B bar I cannot take as y-axis because B bar is inclined. So whenever you have any inclined vector, what you have to do, you can resolve that vector into components. You can resolve that vector into components. So how to resolve this? As you know, we'll drop perpendicular. We'll drop one perpendicular. So what is the angle here? 90 degrees. Now, if you look at this A bar, or I can say vector A bar or component of vector touching the angle theta. So what should be this side?
Cos theta.
Cos theta. So which cos theta you will get? A cos theta or B cos theta? B it long. This is B bar.
B.
A cos theta.
A cos theta.
No. B cos theta. B bar is getting resolved into components. B bar is getting resolved into components. Here what you
Sir,
get
once
is
repeat it, sir.
B cos theta. And where you get B sin theta now? B sin theta.
When the
On
B
inclined
component
B
is
side.
resolved into y-axis, sir.
Yes. So along y-axis, B cos theta is nothing but what? Along x-axis. If I consider A bar vector along x-axis, then B cos theta is the component of vector B bar acting along vector A bar. And here I can write this one as B sin theta. But which component is acting along A bar? Which component of vector B is acting along A bar?
B cos theta.
B cos
B
theta.
cos theta, sir.
B cos theta, sir.
Then I have to multiply this component of B bar, which is acting along A bar, with A bar, with magnitude of A bar. So how can I multiply? B cos
AB cos
theta
theta.
into modulus of A bar, because I am finding out magnitude. B cos theta into modulus of A bar is defined like this, is defined in such a way that A bar dot B bar. So now I can write A bar dot B bar is equal to modulus of A bar. As you know, I can write simply A into B cos theta. So I can write like this, B cos theta into A. B cos theta into A. So from this, or simply I can write A bar dot B bar is equal to AB cos theta. This is the formula I got. Now you may raise a question. You might get a doubt, like why we have to resolve only vector B bar? Why can't we resolve for vector A bar? We can also resolve vector A bar into components. If I resolve vector A bar into components, then what I have to do is, I have to draw one perpendicular from A bar on B bar. I'll show you. B cos theta is the component of vector B bar which is acting along A bar, so that I can multiply these two. How to multiply? B cos theta is the component of B, and A bar, magnitude of A bar I need to multiply with, so that I can get the final result. I am defining it as A bar dot B bar. Multiplication it define చేస్తున్నాం. A bar dot B bar అంటున్నాం. We are naming like this. A bar
Sir,
dot
could you
B
explain
bar.
it?
ఏందన్నా?
ఒకసారి మళ్ళీ ఎక్స్ప్లెయిన్ చేయండి.
Okay.
B
This is vector A bar. This is vector A bar, and this one is vector B bar. So B bar is resolved into components. B bar is resolved into components. And how to resolve vector, as you know very well, I will show you again. Like if I have coordinate axis, x and y axis, here you have a vector A bar which is making an angle theta. How to resolve this now? I will drop two perpendiculars from this. One along x-axis, one perpendicular is dropped along x-axis, and the other perpendicular is dropped along y-axis, so that what you will get here? You will get
A cos
along
theta.
x-axis A cos theta A cos theta. Simply I can write this one as AX. AX is equal to A cos theta. What about this one along y-axis?
A sin theta.
A sin theta.
AY is equals to A sin theta.
A sin theta. When this is A sin theta, what about this one?
A
A
sin
sin theta.
A sin theta.
A sin theta.
Now here I am showing you by dropping one perpendicular on A bar, right? So here B bar is when I resolve this B bar into components, one component here, as you see here, you can see A cos theta, which is acting along x-axis. Similarly, B cos theta is the component acting along which vector? Acting along A bar. And what about other component? Both are same here. This one, this line you see, this line you see.
Yes, sir. B sin.
So B bar की theta के opposite में sign वस्तुंड. Whenever angle you consider, for theta opposite side is always sine. So theta के opposite A sin direction. So what should I get here? B sin theta. And nothing to do with B sin theta here because B cos theta is the only component of vector B acting along A bar. So I need to multiply these two to get the final result as, I'm denoting final result as A bar dot B bar. So A bar dot B bar is equal to nothing but B cos theta into modulus of A bar. Modulus of A bar is nothing but A only simply. So A bar dot B bar is equal to B cos theta into A. And finally, I'm getting the same result. A bar dot B bar is equal to AB cos theta. Formula గుర్తుపెట్టుకున్నాను. Nothing to do with, nothing to do much with the theory, right? So this is how we have defined dot product of two vectors is equal to AB cos theta and define this. Now, how can I resolve vector A bar? Let me show you that one also. If I want to show the resolution, see, let me take the same figure. This is B bar, this is B bar, and this one is A bar, and theta is the angle. Theta is the angle between A bar and B bar. Now, if I want to resolve this A bar into components, now what I will do is, let me extend this. Now let me drop one perpendicular on B bar. In the previous case, from where I have dropped a perpendicular?
Head of
From
that.
B bar to
Head
A
of
bar.
B vector.
Second vector B bar.
B bar.
Head of second vector to B bar, right? Now here what I am doing, I am dropping one perpendicular from head of first vector to second vector. Head of first vector to second vector. What is second vector? B bar. Now where is 90 degrees? This is
Near the B bars.
90 degrees. Now ఇప్పుడు theta కి ఏది టచ్ అవుతుందా? For theta which angle is touching? I mean where you will get cos. Now you are resolving A bar into components. A bar ni resolve చేస్తే here what you will get and here what you will get.
A bar will be cos na sir.
A bar cos వస్తున్నాడు. But where you
A
get
cos
and where you
theta.
get sin? Where
A
you
cos
get
theta
cos
and
and
A
where
sin
you get
theta also.
yeah, ఎక్కడ వస్తుంది? A bar cos theta ఎక్కడ వస్తుంది? A bar sin theta ఎక్కడ వస్తుంది? Or not A bar, A cos theta simply, or modulus of A cos theta ఎక్కడ వస్తుంది? Modulus of
On A
A
bar
cos
sir.
theta.
A cos theta on A bar.
B bar మీద A cos theta వస్తుందా
B
సార్?
bar మీద A cos theta వస్తుంది.
B bar మీద A cos theta.
And theta के opposite side. This will be.
B sin theta.
A sin theta.
Now if you look at the figure carefully, along the second vector B bar, A cos theta is acting. So I want the multiplication of these two. Then I can write here this one as, I can define again dot product like this. A bar dot B bar is equal to A cos theta into modulus of B bar. Modulus of B bar. Now final result what I will get? Am I getting
B
the
sine
same
AB
thing?
cos theta.
This is nothing but AB cos theta. Now, do I got the same result in both cases?
Yes, sir.
Yes, sir.
Yes, right? I got the same result. So, final answer, remember A bar dot B bar is equal to magnitude. How can you define this? In order to define this dot product of two vectors, if when you remember the formula, you can define it. Dot product of two vectors A bar and B bar is equal to, what is this A called? Magnitude of A. What is
Magnitude
this
of
B called?
A bar.
Yes. What is this B called? Magnitude of vector
Magnitude
B.
of B bar.
Magnitude of B.
Right? And what I am doing here, A into B.
Multiplication.
Into means what? Product. Into means what? Product. So I can define this dot product of two vectors A bar and B bar as the product of the magnitudes of two vectors and angle. Where is the angle I have considered? Angle is between A bar and B bar. So which angle I got? Cos. In both cases I got cos. So the product of the magnitudes of two vectors and the cosine of the angle between the two vectors. And the cosine of the angle between the two vectors. This is called as dot product. Whether you can resolve second vector into components or you can resolve first vector into components. Finally, I am getting the same result in both cases. Finally, I am getting as A bar dot B bar is equal to AB cos theta. This is the final answer. Right?
Sir,
So,
why only
in
we
both,
considered only cos theta, sir?
oh no, the cos theta no, sir. The cos also. In both cases, you will get cos. Because that component only is acting along the other vector. If I consider second vector B bar component is not. B cos theta is acting along A bar. In this case, A cos theta is acting along second vector B bar. So in both cases, cos term will come, and that is the reason when we'll define like this: cosine of the angle between two vectors. మనకు సైన్ వస్తుంది that we'll discuss for cross product or vector product that we'll discuss later on. But for time being, గుర్తుపెట్టుకున్నాను, this is very important formula. Based on this, you have many numericals. చాలా వస్తాయి. Okay. గుర్తుపెట్టుకోండి. And now we have some characteristics, or you can say properties of dot product or scalar product. Properties. Let me write. Properties of dot or scalar product. Properties of dot or scalar product. Right. Now, first one, first of all, you have to remember the formula. What is the formula? A bar dot
B bar is equals to AB cos theta.
AB cos theta. Right. Now, from this formula, if I ask you if theta is equal to 0 degrees, how the vectors will act? If theta is
We'll get
equal
null
to
vector,
0,
sir.
null vector kaadu madam.
We'll get null vector.
No.
Parallel vectors, sir.
Anti-parallel, sir.
లేదు మేడం. 0 అంటే ఎప్పుడు కూడా
Parallel.
ఇది A bar అనుకోండి. This is B bar. Actually, this is theta. Now, what I'm doing is I'm making B bar to lie on A bar. I'm making this B
Parallel.
bar to lie on A bar. Then these two vectors are in the same direction. These two vectors are in the same direction. I can say collinear also because they are on the same line. Parallel vectors are ఎప్పుడంటాం మనము I mean they are parallel vectors, but they no need to be equal vectors. Equal vectors అంటే ఏందా? Equal vectors means what?
Magnitude should be
Having
same.
same physical quantity.
Magnitude should be same, sir.
Right? And they should be of same physical quantity. But here when B bar is lying on A bar, theta is equal to how much? 0 degrees. In
0
this
degrees.
case, what you will get the answer? If I ask you for two parallel vectors, if A bar is parallel, then angle between two vectors is 0 degrees, then what is the dot product of those two vectors? Cos
One,
0. Cos 0 is 1. But finally, what I'm getting? Dot product of A bar dot B bar. I mean, dot
AB,
product
sir.
of
Is equals to AB.
Product of their magnitudes.
AB. Yes. Simply magnitudes of signal. So first condition, first property, let me write to you. First one is, if theta is equal to 0 degrees, that means A bar is parallel to B bar. Then I can write like this: A bar dot B bar is equal to AB cos 0 degrees. Cos 0 is 1. So simply you will get AB since cos 0 degrees is equal to 1. Right. So this is first one I have written as a property. If theta is equal to 0 degrees, that is A bar is parallel to B bar, then A bar dot B bar is equal to simply AB you will get. Right. Second one, if theta is equal to 90 degrees, that means A bar should be perpendicular to
0.
B bar. Yes, in this case, what I will get? Then A bar
AB into 0, no, sir.
AB into cos 90, but cos 90 is 0. So when cos 90 is 0, finally I am getting the result as 0. Remember, very, very important, whenever I say if two vectors are perpendicular to each other, then their dot product is dash.
0.
If two vectors are perpendicular to each other, then their dot product is always 0. Very important. Make it tricky to answer questions. Make direct theta 90 another. When two vectors are perpendicular to each other, then they is 0. So therefore, I got A bar dot B bar is equal to 0. When A bar is perpendicular to B bar, or I can say both vectors A bar and B bar are perpendicular to each other, then the dot product is equal to 0. This is second one. Now if I say, if I give the angle between two vectors as 180 degrees, if the angle between two vectors as 180 degrees, third one,
Minus AB.
minus 80 now. Theta 180. That is, I can say that A bar is anti-parallel to B bar. Then in this case, what I will get? Then A bar dot B bar is equal to AB
into cos
minus
minus
1.
1.
So AB into minus 1, since cos 180 is equal to minus 1. So therefore, finally what I got? I am getting the result of dot product of two vectors. A bar dot B bar is equal to minus AB. Fine. So this is third one. Now, as you know that a vector can be resolved into components. If I ask you in three-dimensional space, can I write bar x?
Sir, video is tracking.
Video stuck అవుతుందా?
No, sir.
No,
It's
sir.
clear for us.
Clear only, sir.
How can I resolve this vector into components along three different axes?
AX I cap plus AY J cap plus AZ K cap.
AZ K cap.
Plus AY J cap plus AZ K cap. And similarly, can I write B bar as
BX I cap plus BY J cap plus BZ K cap.
plus BZ K cap? But before doing the dot product, now let me explain what is the value of I cap dot I cap. I'm showing you these two. A bar, I can resolve this into three components along three different axes, three mutually perpendicular axes, as AX I cap plus AY J cap plus AZ K cap, and B bar is equal to BX I cap plus BY J cap plus BZ K cap. Right now, let me show you before going to do the dot product of these two. I will show you these three things. These three are very, very important. Remember, number 4, what I am doing is I cap dot I cap. What is the value of I cap dot I cap?
1, sir.
Why 1?
Magnitude
cap.
of unit vector is 1, guys.
Now,
Two I cap.
if you A bar dot B bar in rational, what is the form?
AB cos.
AB cos
Two.
theta.
Magnitude of B bar into cos
Cos
theta. But I cap dot I cap. I cap is along x-axis. Another I cap is also lying on x-axis. Then that means how are these two vectors, unit vectors?
Parallel, sir.
One I cap is parallel. What is the angle between two parallel vectors?
0 degrees.
0.
0 degrees. So can
Ante-
I write like this?
2 I cap direct.
Modulus of I cap into modulus of I cap into cos 0. What is the value of cos 0? 1. What is this magnitude vector? Magnitude of unit vector is equal to 1. So 1 into 1 into 1.
1.
1 into 1 into 1 is equal to 1. So I got I cap dot I cap is equal to 1. Right? Similarly, if I ask you J cap dot J cap.
1.
1, sir. Modulus of J cap. What is the angle between J cap and J cap? J cap is lying on y axis.
0 degrees.
J cap is also lying on y axis. So cos 0 degrees. So what I will get? 1 into 1 into 1 is equal to 1. What about K cap dot K cap?
1.
Modulus of K cap into modulus of K cap into cos 0 degrees is equal to 1 into 1 into 1 is equal to 1. Right? Now, based on these three, can I write all the three at one place? Like this.
I cap dot J cap dot K cap.
J cap dot J cap is equal to K cap dot K cap, all are equal to
1.
1. Remember this. I cap dot I cap is equal to J cap dot J cap is equal to K cap dot K cap is equal to 1. right? Now you can ask, man, why we are taking only between I and I? Can't we take between I and J? Can we take between I and J?
Yes, sir.
We can take. Let's see what we'll get.
It will be
Fifth
90
one.
degrees, na, sir?
2D na sir.
So
Yes, sir.
fifth one. I cap dot J cap. Now I vector, unit vector I cap lies along which axis?
X-axis,
X-axis.
J cap
Y-axis.
lies along which axis?
y-axis.
Y axis.
90
What is the
degrees.
angle between these two?
90 degrees.
90 degrees.
90 degrees. Modulus of I cap. into
0, sir.
Modulus of J cap. Yes. Into cos 90 because 90 degrees is the angle between I cap and
0.
Yes, this is equal to 1 into 1 into 0, which comes out to be 0. Remember, I told you just now one point. If the two vectors are perpendicular to each other, then their dot product is always 0.
0.
I cap and J cap, how are these two? I cap and J cap are perpendicular to each other.
Perpendicular.
When these two vectors are perpendicular to each other, then their dot product is equal to 0.
0.
Now, what about J cap dot K cap?
0, sir.
Same, modulus of K cap into modulus of K cap into cos 90 again. So what I'm getting is
0.
1 into 1 into 0, this comes out to be 0. Now if I ask you the dot product between K cap and I cap.
0,
K
sir.
cap and I cap. Yes. K cap dot I cap is equal to modulus of K cap into modulus of I cap into cos 90 degrees, which comes out to be 1 into 1 into 0 is equal to 0. So finally what I can write? Finally I can write
I cap dot
I
J
cap J
cap
cap
is equals to J cap
J
dot
cap
K
dot
cap
K
is
cap
equals to K
equals
cap
to
dot J
K cap
0.
dot I cap.
So I cap dot J cap is equal to J cap dot K cap is equal to K cap dot I cap is equal to 0. And remember these two results, I cap dot I cap is equal to J cap dot J cap is equal to K cap dot K cap is equal to 1. And I cap dot J cap is equal to J cap dot K cap is equal to K cap dot I cap is equal to 0. Right? And one more important property, dot product of two vectors obey, or dot product of vectors obey commutative law. Dot product of vectors obey commutative law. As you know, we have studied about commutative law and addition. There we
And subtraction also. Sir.
subtraction also, but in subtraction it will not obey commutative law. It will
Yes,
not
sir.
obey commutative law. Commutative law is obeyed only under addition.
Distributive law only
Right. A bar plus B bar is nothing but B bar plus A bar. This property we have written under addition. If you just recall, under properties of vector addition, commutative law obeys. Similarly, dot product of two vectors or dot product of even three vectors, if I take, it will also obey commutative law. I can write like this: A bar dot B bar is nothing but AB cos theta. Is it not? A bar dot B bar
Yes,
is
sir.
equal to AB cos theta. Or I can write like this. Better way, I can show you again. A cos theta into modulus of B bar. Because one component will be acting along the second vector. What is this here? A cos theta is one component of vector A, which is acting along the magnitude of B bar. So this can be written as what? A cos theta into B. Finally, what I can write? AB cos theta. AB cos theta. Now, how to show commutative law? Here, what I have written? B bar plus A bar.
B plus A.
Now, what I have to write here? B bar dot A bar. What I should get? Here, A bar dot B bar I have written as A cos theta into component of second vector. Now, what I will write is B cos theta into modulus of first vector, which is nothing but B cos theta into A. What I am getting the final result? A B cos theta. Are they same?
Yes, sir.
Both are same. So therefore I can say that A bar dot B bar is equal to B bar dot A bar. A bar dot B bar is equal to B bar dot A bar. This is obeying commutative law under multiplication. Obeying commutative law under multiplication. Right?
Sir, what
Now,
about associative law and distributive law?
yes, they will also obey now. A bar dot B bar dot C bar. I can write like this. I can just show you A bar, but this is not in our syllabus, right? I'll just show you. A bar dot B bar dot C bar can be written as A bar dot of B bar dot C bar. Okay. So anyways, we can do this. I mean, you can try. If you don't get, I'll let you know. How to try? You have to consider A bar as AX I cap plus AY J cap plus AZ K cap. And how to consider B bar? B bar is equal to BX I cap plus BY J cap plus BZ K cap. And how to consider C bar? C bar can be resolved into three components. If I consider three components along X, Y and Z axis as CX I cap plus CY J cap plus CZ K cap. If you, after taking that, if you multiply, you will get the LHS is equal to RHS. You try this. If you don't get, I'll let you know. Okay. Fine. Now, let me show you. If A bar is equal to AX into I cap plus AY into J cap plus AZ into K cap. That means I have resolved vector A bar into three mutually perpendicular components, AX acting along I cap, AY acting along J cap and AZ acting along K cap. And similarly, if I write B bar is equal to BX I cap plus BY J cap plus BZ K cap. BZ K cap. In this case, A bar dot B bar. If I ask you A bar dot B bar, how to find A bar dot B bar? Now, can I write this A bar as AX I cap plus AY J cap plus AZ K cap dot B bar is nothing but BX I cap plus BY J cap plus BZK cap. Right, sir?
Yes, sir.
A bar, yes, A bar is nothing but AXI cap plus AYJ cap plus AZK cap, and B bar is equal to BXI cap plus BYJ cap plus BZK cap. Then A bar dot B bar can be written as AXI cap plus AYJ cap plus AZK cap. This is A bar. Dot B bar is nothing but BXI cap plus BYJ cap plus BZK cap. Now you have to do the multiplication. As you know, AX first term with the first term in the first vector with the first term in the second vector. If I multiply, what I will get? AX BX I cap dot I cap.
1.
I cap dot I cap is nothing but 1. Remember this, right? Plus first term in first vector with second term in second vector. First నేను అన్ని ఫస్ట్ టర్మ్ తో అన్నిటిని మల్టిప్లై చేస్తున్నాను. ఐఎమ్ multiplying all these terms with the first term of first vector. So what I will get? AX BX అయిపోయింది. AX BY. AX BY. I have to multiply I cap dot J cap.
J cap.
Plus again first term with the last term. First term in first vector with the last term. So what I will get? AX BZ. I have to multiply I cap with K cap. I cap dot K cap. Now plus second term in first vector with all the three terms you need to multiply. Second term to multiply again. You tell me, I'll write.
AY
BX
BX
I cap dot
I
J
cap
cap.
I cap.
Very good. So
J
what I
cap
will get here?
dot I cap, sir.
J cap into I cap.
Dot I cap. AY BY J cap dot J cap.
Very good. AYBY J cap dot J cap plus
AZ K cap.
AY J cap.
Sorry, AY J cap
AY
plus
J cap.
J
AY
cap dot
BY
J cap into I cap.
K cap.
plus.
K cap.
Next one.
AZ K cap.
AZ BX
AZ
I
BX
cap dot K
I
cap.
cap J cap.
I cap dot
Dot K cap.
K cap.
Oh, sorry.
Plus
AZ
plus
K cap dot I. K cap dot I cap plus
AZ BY
AZ
K
BY
cap dot J
K
cap.
cap dot J cap.
K cap dot J cap.
AZ
AZ
BZ K cap dot
K
K cap.
cap dot K cap.
Now here, what is the value of I cap dot J cap?
0.
0.
This is 0. I cap dot K cap.
0.
I cap dot K cap.
0, sir.
Are they same?
No, sir, 0.
Can I say I cap dot K cap is equal to K cap dot I cap? K cap dot I cap.
Yes, sir.
Because it should obey.
Product will be 0 now, sir.
Commutative rule.
Anywhere.
Product will be 0. I cap dot K cap. This product is 0.
Sir,
What about
final
this one?
product AX BX plus AY BY plus AZ BZ also, sir.
And then it is 0. This is 0. And J cap dot K cap. This is 0.
0.
K cap dot I cap.
0.
K cap dot
0.
J cap. This is 0. But I cap dot I cap is
1.
1.
1. AX BX
1,
1 AY BY
So
1.
AX BX is equal.
AX
AXBX
BX
plus
plus AY
AYBY plus
BY plus
AZBZ.
BZ
ఒక్క నిమిషం అన్న, ఒక కాల్ వస్తుంది.
Sir, can't hear you, sir.
ఒక్క నిమిషం నాన్న, ఒక్క నిమిషం తీసుకోండి. ఓకే నాన్న, సో ఫైనల్ ఏమొచ్చింది మనకి? వాట్ ఈస్ ది ఫైనల్?
AX BX plus AY BY plus AZ BZ.
Okay, so I got A bar dot B bar as AX BX plus AY BY plus AZ BZ. Okay, final result గుర్తుపెట్టుకోండి. No need to do all these calculations. You have to keep the formulas in mind, like I dot cap I dot is equal to J dot J cap dot J cap is equal to K cap dot K cap is equal to 1. That result you have to remember. And I cap dot J cap is equal to J cap dot K cap is equal to K cap dot I cap is equal to
0.
So that finally I got a dot product of two vectors. A bar dot B bar is equal to AX BX plus AY BY plus AZ BZ. Okay, this is one thing important. Okay, now yeah. Now if I ask you, A bar is equal to AX I cap plus AY J cap plus AZ K cap. This implies what is the magnitude of A bar?
Root of AX square plus AY square
Root-
plus AZ square.
Root over AX square plus AY square plus AZ square. Similarly, B bar is equal to BX I cap plus BY J cap plus BZ K cap. Then I can write magnitude of B bar as square root of bx square plus by square plus bz square. Is it not? Anna? Now let me show you one more thing. What is the formula we have for a bar dot b bar? A bar
AB cos
AX
theta, sir.
BX plus
b bar is nothing
AY
but
BY plus AZ AZ.
A bar dot b bar is equal to AB cos theta. This is the definition of dot product of two vectors. Right? Now, can I write like this? What is the, just now we got, if I consider A bar as AX I cap plus AY j cap plus AZ k cap and B bar as BX I cap plus BY j cap plus BZ k cap, what is the value of A bar dot B bar I got?
AX BX plus AY BY plus AZ BZ.
Yes, AX BX plus AY BY plus AZ BZ is equal to A. Magnitude of A is nothing but A. Magnitude of A bar is
Root
nothing but
AX
A.
square
Increase
plus
of A,
AY square plus AZ square.
square root of AX square plus AY square plus AZ square multiplied by
bx square.
B.
Root of
B is
BX square plus BY
bx
square
square
plus
Root
BZ square.
BX square plus BY square plus
BX
BZ.
square plus BY square plus BZ plus under root into
Cos
cos theta into cos theta. Now I want the value of cos theta. From this, I will get cos theta is equal to
AX BX plus AY BY plus AZ BZ divided by
square root of
AB.
A square plus AY square plus AZ square into square root of BX square plus BY square plus BZ square. Remember the formula. Remember as many formulas as you can. Any formulas గుర్తుపెట్టుకుంటే అంత మంచిది. Try to remember all the formulas, as many as you can. Otherwise, you have to derive like me. I cannot remember all the formulas, but you have to remember the formulas. Right? So cos theta is equal to AX BX plus AY BY, or simply I can write like this, or I can simply write this way. Cos theta is equal to, this entire thing is nothing but A bar dot B bar divided by, what is it?
modulus of
AB. AB,
AX
sir.
plus, AB right now. I mean, of course, modulus of A is nothing but AX square plus AY square plus AZ square into modulus of B. What do you get? Modulus of B is nothing but, or magnitude of B is nothing but BX square plus BY square plus BZ square. Okay, so this is how we okay, Nana? So
sir 4 sir.
ఓకే నాన్న అయిపోయింది. సో లెట్ మీ వైండ్ అప్ ది క్లాస్. సో టుమారో మీకు ఇచ్చిన, ఒక్క నిమిషం నాన్న, లెట్ మీ